This lesson covers the introduction to IPv6. IP is really used for the foundation of all communications today. If we look at communications within a company, between desktops, between laptops, to servers, out to the internet, everything is using the internet protocol. Also, if we look at the proliferation of new types of devices, mobile phones, refrigerators, all IP enabled, all can connect to the internet. All of those devices require an IP address. Now remember that the IPv4 is a 32-bit number. So if I open up a calculator, if I say I have 2 to the power of 32, that's how many IPv4 addresses exist. So that seems like a lot, but if you now consider the amount of devices that are out there, there's really no way that can keep up with the demand. Now there are technologies that are there to help. For example, if you're in your home and you look at the IP address, you'll have an IP address either in the 192.168 or the 10.0 address space. Remember, these are the reserved IP addresses that are not routed on the internet. What is actually happening is your gateway to the internet, it maybe has a valid address for the internet. And then it's giving you a local IP address that's used just within your house or indeed your business. When you communicate to the internet, that router acts as a NAT, a network address translation device, and it takes the IP address you're using, the ports you're using, stores it internally, and then re-IPs that packet, that information being sent, with its IP address. So you don't need a valid IP address on the internet. This does apply to large organizations as well. So again, if you look at the IP address being used in a company, it's probably a 192.168 or a 10.0. This means I could have 10,000 machines in my organization and maybe only 2 valid IP addresses at my gateways. So this does remove and reduce the amount of IPv4 addresses I need, but it's still a challenge. Now there have also been improvements in various types of service. For example, if I look here, Windows Server 2012 IIS, Internet Information Services, previously for each SSL, for each encrypted web page, it needed a unique public IP address. In Windows 2012, it can now share an IP address between hundreds of sites. So again, there are things to help improve. However, there comes a point where we will just run out of IPv4 addresses. IPv6 was introduced to really address this challenge, but also to fix some other challenges. For example, if we look at IPv4 today, the packet is very fixed. It has a certain number of fields in the header, and it has limited expandability. IPv6 was built around greater flexibility. You can basically tag on additional headers to the main IPv6 to extend its functionality. This simplifies the packet and can help reduce some of the load on your routing switches, because there's some automated routing information as part of IPv6. The idea of a static IPv6 address kind of disappears. It's such a large address that's not going to be practical. But again, there have been improvements in how IPv6 works that I don't need to apply static IP addresses. I'm going to leverage DNS heavily. I'm going to use dynamic update, and it will just register its IPv6 address for me automatically. So IPv6 is a 128-bit address. So if I bring up my calculator again, and now do 2 to the power of 128, I get this very, very large number. 3.4 times 10 to the 38. So I had to look this up. Basically, this is 340 undecillion. An undecillion is 10 to the 36. And if you took the raw surface area of the Earth, it's going to mean hundreds of IPv6 addresses for every square foot. That includes ocean, everything. So IPv6 really should cure the problem of running out of IP addresses. While I'm actually showing you the calculator, if you think back to our IPv4 days, I remember working out, well, how many bits do I need for the host? How many hosts do I need in a particular subnet? You can always just say 2 to the power of the number of bits you're reserving for the host address. So if I was reserving 8 bits, that shows me how many hosts I could have in that subnet. Now you have to subtract 2 from this number. Remember, there is one for the broadcast and then one for the idea of the network itself. So if maybe I wanted 4 bits, this is just a little useful thing to know, I could have 14 hosts if I used 4 bits for the host ID and the rest for network. So just a useful little calculator tip. Now when I'm thinking about 128-bit address, I think, how do I write that? So addresses are now being written in this format. And really what this is showing you right here is it's 6 blocks of 16 bits. And each of those blocks is written as 4 hexadecimal characters. Now the subnet mask, I'm not going to try and write FFFF:. I just write the number of bits at the end that are actually used for the subnet mask. So this is saying the first 60 bits are used for the subnet mask. Now we still have some of our common addresses that we thought of from the IPv4 days. So if I open up my command prompt, well firstly I can see what my local address is. If I do my ipconfig, I can actually see here my IPv6 address, and this is a linked local address. Now this is a stateless address which I'm going to talk about more later, but this has been automatically generated, but it's still routable. So this is the IP address I'm using, but I have the loopback address. I can say ping : 1, and that's pinging myself. That was the same as the 127.0.0.1 in the IPv4 world. For the unspecified, so any host, is just : And again, we have this auto configuration selection, which was like the 169.254, which is FE80 : which is what you could see for my IP address. Now we can simplify how we write addresses. So leading zeros in a block can be removed, but I still need at least one numeral. So for example, I can see here, instead of writing 0008, I just wrote 8. Instead of 0000, it's just 0. Additionally, if I have multiple blocks of zeros, I can replace them once. So I can't do it in multiple places, but I can just write : And that represents everything in between were zeros. And you actually saw that in my example here. So you'll notice there aren't enough blocks in this address, but you can see I have a : And that's saying those blocks are actually all just zeros. This ends the lesson on the IPv6 introduction and address format.